Hi everyone, Senan this side, and in this video we are going to solve this Geeks for Geeks daily problem, which is kth distance. So you are given an unsorted array R and a number k, which is smaller than the size of the array. Okay, so if the size of the array is n, k is less than n, right? This constraint. Now find the array. Find if the array contains duplicates within k distance. So what does k distance mean? So starting from this, and let's say k is 3. So at max you can do k hops, which is 3 hops, 1, 2 and 3. So if you do 3 hops and you can find a duplicate, you're good to go. In that case you return true, otherwise you return false. In this case as well, since k is 3, starting from 1 I can do 3 hops, 1, 2, 3, no duplicates. Starting from 2 I check in the next 3 hops is there a 2, so 1, 2, 3, no 2's are there. The next case I start with 3 and in the next 3 hops I check if there is a 3, so not here and not here. Similarly you proceed on with the rest of the array and you would see that there are no duplicates within kth distance, right? In this case there is just this one at a distance 3. We have another one, so we return true. We are not considering at what position we are finding this duplicate nor what element it is. We just need to say true or okay. So what would be the brute force way? The brute force way is starting from the first element, do k hops and check if there is a duplicate of that element within k hops. Similarly for 2, 3, 4 and so on till you reach the last element. So in a way you're traversing for n items, and for each n item you are doing a max of k jumps, so n times k, which gives you a time complexity of n times k. But the space complexity would be constant because you're not storing something in this approach. But can we improve this? And the answer to that is actually we can improve this, and to improve the time complexity, we have to compromise on space. So that is what we are going to do. So let's see the approach, and the approach would be to keep track of a window. So since we can have k jumps, right? So k jumps, so let's keep a window of k plus 1. So I'll check for these elements if there is a duplicate. If not, I'll remove this first element and I'll take the next element. This is the second window, the third window, this is the fourth window, this is the fourth window, and finally this is the fifth window. So in every window I would try to check if there is a duplicate, but the way I'm going to keep track of this set is slightly different. Keep track of this window. So what I'll do is I'll keep this window of size k and check the next element, let's say 4, and if this 4 is present in this set I return true, otherwise I take this 4 into this set and I remove this one from the set. So my new set would be this. Now I would check for this one. Is this one in the set? No. So I remove this 2 from the set and add this one into the set. So that is the way I'm keeping track of the window that I'm at. Similarly in this, if k is 3, I am keeping a window of size k, and since I am seeing this one, right, so this one is in the set, so I return true. So I don't even have to check the remaining set. So how do you actually write the code for? So the idea is this: you keep a set, right? You take this unordered set, and what you do is you first insert the first k elements into this set. Now if the first k elements are in the set, so the size of the set would be either k or less than k. So when would it be less than k? It would be less than k when there are duplicates, right? Because set stores only unique elements. If the size is less than k, that means there is a duplicate within this k length subarray, and therefore the distance would be less than k, and that is the reason why I return true in this. Otherwise, if my set size is equal to k, what I'll do is I'll do this operation. So for starting with j is equal to k and j is less than the length of the array, what I do is try to find this array of j in my set, and if I find this, so that means I found an element which is at max kth distance away from me, or from this array of j, and in that case I return true. Otherwise I return the first element of the set or the window, and I insert the new element in the set, and I do this till the time j reaches the end of the list. And if at some point we were able to find a duplicate within k distance, we return true, and otherwise we return false. So that is the idea. And what is the time and space complexity? So this set, like this unordered set, works in big O of 1 amortized space or time complexity, amortized space complexity of big O of 1 of the set. So inserting and erasing is constant time, and finding is also constant. So this for loop actually runs for linear time, big O of n minus k, and this For this as well, we are running for k iterations, so big O of k. So in total, we are running for big O of n time. So this is the linear time solution. What is the space complexity? At any point, my set would be storing exactly k elements. So big O of k would be the space complexity, big O of n would be the time complexity. And yep, that's it. And if you want a written solution with this code, be sure to check out the description for the GitHub link. There I would have the explanation, approach, intuition, everything regarding the time and space complexity of this particular problem. And I'll see you in the next video.